All right, here we go. All right, so I left my writing tablet at school, but you know what? We're going to do this. Quizzes 4, 5, 6, and 7 in limits and continuity. And we're going to start with the factoring problem. So what is rule number 1 of factoring? Divide everything by the GCF. So 2, 4, and 30, the GCF is 2. And then what's the lowest number of x's? X squared. So we'll divide everything by x squared. And the GCF goes out front. Okay. And then what does that make this? X squared in front. And 4x cubed divided by 2x squared is going to be 2x. So plus 2x. And 30 divided, that's 15. So it's minus 15. And then we always want to see if the trinomial on the inside factors. Usually, sometimes does. And this one, I'm thinking positive 5 and negative 3. X plus 5, x minus 3. By this time, you should be factoring champions in your math career. And we have factored it completely. So 2x squared, x plus 5, x minus 3. Ta-da! All right, factor it completely. This one is a difference of squares. And the squares are, there's no GCF, it's just 9 minus 2x, 9 plus 2x. I love difference of squares. I hope you do too. All right, I factored. Well, I'm not factoring. I'm not factoring anymore. You can factor. Oh, but this one we must factor because this has 4 terms. How do we factor with 4 terms? We factor by grouping. So we're going to look for the GCF in the 2 and then the 2. So in the first one, there's a GCF of x to the 4th. And that leaves us with x minus 1. In the second pair, there's a GCF of 3. And that would also leave us with x minus 1. And now we see both terms have the factor x minus 1. So we can factor out that GCF. And then what's left is x to the 4th plus a 3. Oh my. Okay, so x minus 1, x to the 4th plus 3, close parentheses. All right, having fun on this one. Factor complete, that's different squares. You could do it, you don't need my help. Moving right along. All right, quiz 5. 6 questions. Oh my goodness, we are switch gears, everybody. All right, radians, degrees. This is when, all right, so the degrees can be changed to the radians, and the radians can be changed to the degrees. If you start in degrees, you multiply by pi over 180, and then that gets you into radians. And then if you start with the radians and you want to go to the degrees, then you just multiply by 180 over pi, and that gives you the degrees. And I can remember that easy because if I want to go into radians, I know I want pi, so put that in the numerator. But if I want to go out of radians, I put pi in the denominator so that it will cancel. Or even if it won't cancel, pi is in radians even if you don't write it. So we got 310 degrees, so all we got to do is multiply that by pi over 180 and express your answer exactly. All right, so let's get rid of those zeros. And then what do we have? 31 pi over 18. You know, 31 is one of those prime numbers, I do believe. So 31 pi divided by 18. Here we go. Mr. Fields on a roll. All right, because, you know, I will get one wrong. I mean, probably. Cotangent. Okay. All right, so let's remind ourselves of so, ka, toa, and then cotangent, cho, sha, kao, cho, sha, kao. So the cosecant is the hypotenuse over the opposite. The secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So you can like go like this. Oop, nope. You know, make the slashes, and then you will be more precise. All right. So, I mean, you remember SOHCAHTOA, right? You're writing this down, right? Or is it ingrained in your memory? It's one or the other. Okay. So we want cotangent, we want adjacent over the opposite, and B is our reference angle here. So what's the adjacent to B? That would be 24. The opposite is 10. 10 over 24. I mean 24 over 10. And you know it says reduce to the lowest form, so would that be 12 over 5? It would be. Okay. The angle theta sub 1 is located in quadrant 4, and cosine of theta sub 1 is 3/5. What is the value of sine theta sub 1? Well, I want you guys to remember a little trick about math people. We love 3, 4, 5 right triangles. So right away, I see the 3 and the 5, and you know, so there's like a gajillion Pythagorean triples, but you see all the time 3, 4, 5. And another one I want to share with you is 5, 12, 13. You see these things all the time. Okay, and then multiples of them, 6, 8, 10. So anyway, but that's you know, cheating a little bit because they want us to go through the process. So let's do. So we are going to draw our axes, and quadrant 4 is down here. You know, 1, 2, 3, and 4, and the cosine is 3/5. So we're going to draw our triangle with the horizontal, and the cosine is 3/5, which means 3 and then fifths, and so that's 4. Pythagorean theorem or Pythagorean triple memorization. And so what is the sine of theta? This is theta, by the way. So the sine of theta would be 4/5. I told you I would get one wrong. Why is it wrong? It's because we're below the y-axis. It's negative 4/5. Got it. All right. So, ooh, unit circle. I love the unit circle. I hope you do too. And so we want to plot points A, B, and C. No problem, because like I said, I love the unit circle. All right, so what are we doing again? Sine of pi over 2. So pi over 2 is up here. Okay. And 0, 1, right? That's 0, 1. Okay. And we know the sine is the y value. So the y value of point A would be the sine of pi over 2. I have so much to say about the unit circle, but I'll save it. It's not for that question. Okay, tangent of alpha in the triangle. Okay. So there's alpha. So what's the tangent of alpha? that's opposite over adjacent. So 21 over 20. Why are you wasting my time? Khan Academy is so easy. Oh, circle again. All right, so the sine of 90 pi over 2 is still right there. Still y coordinate of A. All right. Done with that. Quiz 6, 5 questions, 10 minutes. What is the value of tan pi over 6? Okay, so maybe it's time to talk about our unit circle. All right, get ready to write here. Pi over 6. Let's just do the first quadrant. Pi over 3, pi over 4, pi over 3, pi over 2. So what are the coordinates of these? The coordinates of pi over 6 are the cosine. Oh, of course, 0, right? What are the coordinates of 0 degrees or 0 radians? 1, 0. And then pi over 6, we know is square root 3 over 2, comma, 1/2. What are the coordinates of pi over 4? Let's see, square root 2 over 2 for both x and y. Square, and then these are just switched, so now it's going to be 1/2 square root 3 over 2, and then pi over 2 is 0, 1. So hopefully you see the symmetry in the unit circle here, and hopefully you also see the descending values. So square root of 3 over 2 is the second biggest value. Square root of 2 over 2 is right in the middle. 1/2 is the second smallest value. 0 is the smallest value. And so, and then the y coordinates go in reverse. And then the other quadrant of the unit circle, it's just it's the same, it's the reflection. And then there's, negatives on the x. And then the third quadrant, everything's negative, but it's like the same thing. It's just everything's negative. And then the fourth quadrant. So you need to memorize the unit circle. So when I have the unit circle memorized, so when I see tan of pi over 6, I'm thinking about pi over 6. And tan, and so that's right, that is right here. And tan is sine over cosine. So we needed the sine of pi over 6 over the cosine pi over 6. All right, so what's the sine of pi over 6? 1/2. What's the cosine of pi over 6? Root 3 over 2. And like I said in the first video, the difficult part about calculus is not the calculus, it's the little arithmetic stuff. So we got to put these fractions, we got to flip and multiply, and we get 1 over root 3, and we even got to rationalize, and we got to do all like champs. So that is equal to root 3 over 3. And why is that? Because to rationalize the denominator, multiply the top and the bottom by the root on the bottom. And so that makes 3 on the bottom and root 3 on the top. So the tangent, and see, I did not mind that, and so you need to get to the place where you don't mind it either. So the square root of 3 divided by 3. All right. So without a calculator, no problem. Evaluate the following expressions to the nearest hundredth. Without a calculator? Oh my gosh. No, No, not this kind of stuff. All right. Right. So let's think about this. Let's think about this. It's been like years since I've done this. Without a calculator. Okay, so sine of pi minus theta, sine of pi plus theta. So pi is 180 degrees, you know? And so 180 degrees is like that, right? So are we thinking if we want to, and then if we have pi minus theta, so we start at pi, and then we subtract theta, then we'd be right here. So that is pi subtracting theta. It'd be right here, which is a reflection across the y-axis, and the sine is the y value. So I'm thinking it's going to be 0.84. All right, just reasoning through, just thinking through it for the first time in years here. And then the sine of pi plus theta. So now we're going to start at pi. We're going to add theta. So now we're here. And so now it's going to be a rotation of 180 degrees. So it's going to be negative 0.84. Let's see if I got it or if I made a mistake. I got it. All right, let's go. Okay, so find the following trigonometric values. Okay. All right. So 315. Is that one of our staples? Let's talk about this unit circle. When we're doing the unit circle, we count by 45s, and we count by 30s. So 45, 90, 135, 180, add 45 to that, 225, add 45 to that, was it 270, add 45 to 270, you do get 315, don't you? Then if you add 350, 45, so that's 360. So, all right, so 315 is one of our staple values. Not just that, it's one of our staple pi over 4 values, right? So all these are the 45s or the pi over 4s. So they all have the root 2 over 2. And this one is in the 4th quadrant. So it has the root 2 over 2. Which one's negative? Well, it's on the positive side of the x-axis. So that's going to be the positive 2 over 2. But the sign is below the x-axis. So that is going to be a negative. All right. Oh man. All right. Find the cosine of angle BAC plus 30. All right. All right. If you must. Can we use a calculator? Okay, so the cosine of angle BAC. So BAC is this angle is angle A. You know that. And the cosine of BAC. So what is the cosine of BAC? It is 12 over 20. Cosine of BAC is 12 over 20. All right. I'm going to pause the video because I do not have my sum and difference formulas memorized. I'll be right back. All right. I have found the trig and identity study sheet. I'm sure you have. We got our quotient, reciprocal, even, odd, Pythagorean identities, co-function identities, sum and difference. So when I saw this one, I said, oh, we need, we got the cosine of that plus that. And now, the novice would say distribute the cosine angle BAC plus cosine angle 30. But we know better, we know better. Okay, so we're not going to do that. We are going to use the sum. All right, so if it's plus inside, then it's minus in the identity. So in cosine, cosine, sine, sine. So let's do that. So we're going to do cosine, cosine, sine, sine, right? And then it's minus. Bad day to forget my writing tablet. All right, so the cosine of 12, 20, cosine 30 minus sine 12, 20, sine 30. Oh, whoopsies. It's not cosine 1220. It is 1220. So that makes it a little easier. And then and it's actually going to be the sine says 16 over 20, right? That's the sine of angle A, so 16 over 20. All right, we're going to get this here. We're going to get this. So cosine 30 is √3 over 2. And 12 over 20, come on, let's reduce that. Let's stop being silly. So that's going to be divided by 4. We get 3/5 times 3/5. And 16 over 20, that's 4/5. And then sine is 1 times 1/2. So you see again, with the calculus, you must be able to do the fractions easy. If you can't do fractions, you gotta practice. And why can't you do your fractions? All right, so 4. How did you get to this class? Anyway. All right, so 3 and 3, √3 minus 4 over 10. So some version of that, possibly. 3 over 10 or 3 minus 4/10, 2/5, 4/10. Got it. I got it. All right. Oh, goodness. Okay. The angle measures of triangle RTS are in radians. Great. I'm so glad. What is the value of the sine of pi over 3? Square root of 3 over 2. Okay. Remember that unit circle? All right. All right. So let's do this last one. 5 questions, 10 minutes. Oh my goodness. We have descended to rational functions, polynomials over polynomials. And the number 1 rule is to factor. And the number 2 rule is to find our asymptotes and our removable discontinuities. Okay, so let's factor. X squared plus 2x minus 15. I did that one. That's x plus 5, x minus 3. Back to the bottom. Oh, x plus 5, x plus 5. All right. So what are the vertical asymptotes? Would be the non-removable zeros in the denominator. And so I see I can reduce this, get rid of 1x plus 5, and then it would become that. So we have a vertical asymptote at x equals -5, because of course that would make the denominator 0. That's a vertical asymptote. And at 3 is, well, 3 is nothing. You plug in 3 just fine. It's just, but you would get 0. 0 over 8, which would be 0. But it's not a point of discontinuity. Now the removable discontinuity would be, let's pretend that this factored and had an extra x or x minus 2 or some other factor. And so if it was x that canceled out on the top and the bottom, that would be x equals 0 would be a removable discontinuity. In calculus, we would see, well, we would see the graph. It would look just as it would without that factor, but there would be an open circle, right, where there was supposed to be a y value. And using calculus, we can easily find what that y value is. Actually, I mean, it's pretty easy without calculus, but just the beginnings of calculus. All right. Afia tried to perform the following multiplication and reduce to the lowest terms. Okay. You figure that out. You figure that out. Okay. Answer 2 questions about the following rational. All right. What is an equivalent expression in lowest terms? So you're going to factor it like I did in the first one, and you're going to write the, and then any zeros in the denominator must be excluded. So, sorry, I'm not trying to be lazy, but I already explained this in the first one. So, all right, this is new though. We're going to do this one because look at this infinity notation. I'm loving it. This is very calculus-y. And so we want to know the end behavior of this rational function. If you haven't seen rational functions, they're beautiful. All right, so graph it, look at it, this is the basic one. I mean, that is the basic function. How cool. Show that to an Algebra 1 student. Blow their mind. You can go like this, and it just comes from some vertical asymptotes. Craziness, what you could do with rational functions. So let's talk about the end behavior. So when we're talking about end behavior, we look at the leading terms. The leading terms are the same, then what does that mean here? Let me pause the video and refresh. It was not fun to find a little resource, all these tag-on websites. So, all right, let's just look here. P is the numerator and R is the denominator. So if the degree of P is less than the degree of R, then the vertical asymptote is 0. The horizontal asymptote is 0. If the degree of P and R are equal, then it is the fraction of the leading coefficients. It forms an oblique asymptote. And if the degree of P, the numerator, is greater than R, then you do polynomial division and the graph behaves like that. All right, so back to our problem. This is the degrees are the same, and the leading coefficients are 1 and -5. So it's an oblique asymptote. F of x, pick a value. Okay, so let's see. So f of x goes towards -1/5 on both sides. Oh wow, look, I got it. All right. See, easy. Okay. What mistake did Jasper make? You can figure that out. Figure out Jasper's mistake. All right, so that's quizzes 4, 5, 6, and 7. And so now you try them and post in the organizer your green, yellow, and red problems.